Yeah. It's the difference between TWO and TOO, right? Okay. Note that these are different proportions, aren't they? Different ratios. Peroxide acts a lot different than water does, doesn't it? Has extra oxygen, there's much more reactive. Water's not very reactive. Okay? Table salt, sodium chloride. 1 sodium, 1 chloride. Sugar, in this ratio, 12 carbons, 22 hydrogens, 11 oxygens. Okay? And it acts a certain way in this ratio. Okay? That's what defines it as being sugar. Okay? These are all compounds. Mixtures of elements in a fixed ratio. Does it matter if I get this water out of the drinking fountain at Infinity Hall or out of the Marianas Trench? What's the ratio going to be? Still going to be 2 hydrogens and 1 oxygen. Right? Go ask the water boy, he'll tell you. Great big. All right. Now, mixtures are different than pure substances. So pure substances were either elements or compounds. Mixtures now are different. Mixtures are combinations of substances. Okay? And they can be physically mixed, but not chemically combined. And because all they are is physically mixed, we can separate them back out. Anybody know any good examples of a mixture? My favorite one is seawater. It's mostly water. It has a whole lot of salt and stuff in it, doesn't it? Can I separate that salt back out?
Yes.
Yeah, how do I do that? Well, when you go swimming and you get out of the water at the ocean, what happens? All the water evaporates and you get a nice little coating of salt on you, right? Dog comes over and licks on your skin because it tastes good. It does. Now, there are 2 types of mixtures. There's homogeneous mixtures and there's heterogeneous mixtures. Homogeneous mixtures have the same composition throughout. No matter where you take a sample from, it will be the same. In this example, they have a brass spittoon, it looks like. So if I look at the brass over here versus the brass down here or up here or over here, it will all look just like this. It will have the same mixture like this. Okay? And it's a mixture of copper and zinc. Another example of homogeneous mixtures are diver's tanks. I hope that mixture is the same so that when the diver goes down, he has the same mixture at the beginning as he does at the end of his dive, right? Now, he probably won't empty the tank out, but it'll be close down at the bottom, right? Or towards the end of the amount of gas in there. Okay? So the mixture will be the same all the time he's breathing. True? That's a homogeneous mixture. It's the same throughout. Now, a heterogeneous mixture is different throughout. It changes. So the example that I have here is a cup with some pennies in it. And I don't know why anybody would do that, but I have a better example. Who in here grew up in North Carolina? I did. What do we drink in North Carolina?
Sweet tea.
Sweet tea. Pepsi. Sweet tea works for the example, Pepsi don't work. Okay. Does your sweet tea taste the same in the first sip and the last sip?
No.
Why not?
The sugar settles in the bottle.
No, the sugar does not settle.
No, it doesn't.
If you make it correctly, it doesn't settle. It stays the same all the way throughout.
That's right. If the ice melts.
Well, I'm going to say we're not putting ice in the ice doesn't melt. Or, in my case, you drink it so fast that the ice doesn't have time to melt. It tastes the same all the way from the beginning to the end.
That's right.
Homogeneous. This is North Carolina. Homogeneous. However you spell that. Going in. So one of my students in the other class said, Illinois tea. Go in a
Oh,
restaurant,
no.
this your first time going there, you didn't know. You ordered a glass of iced tea. And they brought it to you.
Unsweet.
It has no sugar.
And it is unsweet.
Has ice on
Yeah,
You
and
didn't know Orleans either. You can't get sweet.
No, but, well, you can ask, actually, Louisiana, you can ask for both.
I'm saying above the Mason-Dixon line, y'all been.
You're in trouble. There are states in the South, like Louisiana, if you don't specify, they will bring you unsweetened tea. But you can't, you have to ask and they will bring you sweet tea. I lived in Louisiana for 12 years, so, yeah.
But they actually don't make it above the Mason-Dixon.
Yeah, no, they just don't. Or they bring you some kind of Nest tea, lemon or powder crap,
Yeah.
right? So here we go. What happens?
You have to mix some sugar.
So I'm gonna add some sugar in here because they brought me unsweetened tea. I'm already pissed because I know what's gonna happen. I'm gonna put my sugar in blue. What happens to my sugar?
It just sinks to the bottom.
And it doesn't even sweeten it.
Hardly at all, does it? You stir it, and maybe you get a little bit up here,
Yeah.
but there's gonna be a lot more down here. So what happens? The first sip tastes like absolute,
Yeah.
right? And then by the time you get down to the bottom,
You drink it.
you got a whole bunch of wet sugar left down here, right?
Yes.
Homogeneous, heterogeneous. Okay? Not the same throughout. My tea that I make at my house, when I have it in the pitcher in the fridge, it tastes the same. Every glass I get out, it tastes exactly the same. Right? This crap,
It's a shock to your system, man.
it's awful. The only way to overcome it is to put Splenda or something, because Splenda dissolves in cold temperature. But it still don't taste right, right? You see the difference between heterogeneous and homogeneous? Okay. In this class, we will deal mostly with homogeneous solutions. Heterogeneous solutions are difficult to work with. We won't say too much about them. We might say a little bit. So this is kind of like a diagram to show you what we just talked about. If you put a line right here, here are pure substances, either elements, which are on the periodic table, or combinations of elements called compounds. Once you mix these things together, you get mixtures, either homogeneous or heterogeneous, okay? Homogeneous means the same throughout. Heterogeneous means it's not the same throughout. So, which of these is a pure substance or a mixture? Pasta and tomato sauce, pure substance or mixture? It's a mixture, right? Aluminum foil? We said it's a good example of a pure substance, right? Helium?
Mixture.
It's
Helium is an element.
Okay.
It's element number 2 on the periodic table. It is a pure substance. Air?
mixture.
It's a mixture, mostly nitrogen and oxygen. Okay? All right? These are all mixtures. Are they homogeneous or heterogeneous? Now, this hot fudge sundae, we're not talking about you weirdos that take it and stir it up like that. That's not normal. Don't do that.
That's hetero, because it tastes different.
It's heterogeneous because sometimes you get whipped cream and chocolate fudge and just a little bit of ice cream, and sometimes you get mostly ice cream, right? So not every bite's the same, so it's heterogeneous. What about shampoo? It should be homogeneous, right? I don't know, I don't use it. What about sugar water? In North Carolina, we make it, it is homogeneous. It should be homogeneous. If it, yeah, it should be homogeneous. When you, sugar water, think about a Pepsi or a Mountain Dew. It's got a lot of sugar in it. It's homogeneous, isn't it? It's got the same amount of sugar top to bottom. Peach pie. Yeah, because sometimes all you get is crust.
Your pie's right.
I don't like crust. I like the part with the ice cream and the filling and a little bit of crust. Who puts ice cream on their peach and apple pie?
I think you can bring us.
It's definitely better. I like
And what about yours?
So demonstrate.
Yeah. No, unless your peach pies are all crust, then I don't want it.
I made a
No,
lot.
I hate crust. I don't like crust.
I made a lot.
Actually, I like apple pie better than pizza pie.
I quit making pies when I moved here and I found the crisps y'all make down.
All right,
Oh my God.
here's what we're talking about: separating things out. Right? Does anybody reckon? Anybody ever seen anything look like that? In the deserts, like in the Baja in Mexico, and then in the Middle East and some other places in India, they take seawater and they put it into a flat pond like this, and they allow the water to evaporate. That's how they collect salt. Salt is used as money in a lot of places. It's very valuable, right? Go watch the movie Gandhi if you don't know about salt. Who's seen the movie Gandhi? Who knows who Gandhi is?
Right, is that?
Oh, that's sad, y'all.
Oh.
Who knows who Martin Luther King Jr. was?
Oh, I know now.
Now you know who Gandhi was? It's who he patterned his life on, right? Nonviolent
Didn't he
revolt.
like go on strike, a hunger strike?
Have you been on a big hunger strike? Yeah. And then they did a march to the beach to make salt because poor people weren't allowed to make salt. All the rich people own the salt, and that's how they kept people poor, was by not giving them salt. Salt is used as money in a lot of places. Okay. On Monday, we'll start talking about the states matter and how you change between the states matter. How's that? Who has meat for lab tomorrow? Wait, before we go, who has meat for lab tomorrow?
I do.
We are doing 2 labs tomorrow. We're doing density and we're doing the conversions lab. Okay? Make sure you come ready to do both of them.